Hey class, so here's our next question where we have this projectile that's being launched from the ground up over a distance, horizontal distance d, to land on the top of some cliff at point A. So we're given a few pieces of information. We're given the initial speed that our projectile is launched at this 51-degree angle and the amount of time it's in the air. So as always with these, you start with a picture, which we have here, and then you label your different kinematic variables. So I have my list here of all 11 kinematic variables, and let's just go through one at a time and identify which we know and which we don't. X initial, well, that's up to us. Let's go ahead and define our axes in such a way that where it starts is the origin. And so therefore, if those are the axes that we choose, our x initial would be 0 meters. Similarly, y initial would be 0 meters. X final, we do not know, but that's that horizontal distance d that we're trying to figure out, it looks like, in part B. Y final, if we're looking at the entire portion from beginning to end, would be the small h height, which we do not know. We also don't know h max up here, so we'll come back to that a little bit later. Similarly, if we look at our velocities, v initial we don't have a value for in the x direction, although we know since our hypotenuse, our overall velocity is 50 meters per second, v initial x is going to be 50 multiplied by the cosine of the launch angle, 51 degrees, and similarly, v initial y is going to be 50 multiplied by the sine at 51 degrees, and both of those are positive based on our orientation. V final x we do not know, however we do know it'll just be equal to v initial x because for projectile motion acceleration in the x direction is 0. V final y we do not know, ay will just be acceleration due to gravity but down, and the hang time we're actually given in this case to be 5.84 seconds. So now we can try to start solving this different pieces of the problem. The first one asks us for the height h. It wants this. Since we don't know final velocity, a good tip would be to choose the kinematic equation of motion that ignores final velocity, which would be y final equals y initial plus v initial y times time plus 1/2 acceleration in the y times time squared. So in this equation, we know all of our different variables other than the height. Man, this is a little bit of an easy one maybe. So y final, the height that we're trying to find, is just going to be equal to 0, that's y initial, plus v initial y, which again is our 50 meters per second multiplied by the sine of 51 degrees multiplied by our time, 5.84 seconds, plus 1/2 our acceleration, which is negative 9.8 meters per second squared, multiplied by our time. I apologize that I'm getting tight on space here. Quantity squared. So if we do the math, for y final, we get a total overall final height of 59.6 meters. Box-worthy for sure. Part B asks us to find the distance d. So I think using the same kinematic equation but applying it to the x direction seems like the way to go. X final is going to be equal to x initial plus v initial x times time plus 1/2 acceleration in x times time squared. Once again, we have x initial being 0 and we have ax being 0. So all we're left with is x final, the distance we're trying to find, equals initial velocity times time, which again is the 50 meters per second, times the cosine of our 51-degree angle, multiplied by our time of 5.84 seconds. So you should be able to find that distance d has an x value of 184 meters. Boy howdy, it's quite the projectile launcher. So next we're asked to find the impact speed of the stone just before impact at point A. So again, it's looking for speed, so that's magnitude with no direction of the projectile right when it's about to hit. So I'm going to scroll up here to create a bit more space, but what we're going to need here, as we hopefully are aware of at this point, To get our final speed, that's the magnitude of our final velocity, which would be the square root of Vx squared plus Vy squared. So Vx, we know, is just V initial x. So Vx should just be equal to 50 meters per second multiplied by the cosine of our 51-degree angle. So our Vx value should just be 31.47 meters per second. Vy, however, we need to solve for because we don't know the final velocity, but since we know the initial velocity, acceleration, and time, our very first kinematic equation seems like a good way to go since we know all variables in it other than V final. So Vy should come out to be equal to 50 meters per second multiplied by the sine of our 51-degree angle plus a negative 9.8 meters per second squared multiplied by our time of 5.84 seconds. So if we do the math, we should get a Vy that's equal to negative 18.43 meters per second. So let's do it. Does it make sense check? First of all, it's negative. Does that make sense? Yes, it's moving down at the time of impact. Secondly, it's less than our initial velocity in the y direction. That too makes sense since it's ending at a height above where it started. So from there, you should be able to simply do the square root to find the magnitude, which I trust your abilities to do. So I'll just go ahead and give us what we should find, which is a magnitude or a speed of 36.5 meters per second. Boxworthy again. Boom. Now, returning to the problem statement, we should observe that, oh boy howdy, the last thing that we're asked to find is the maximum height h. So to find the max height h, you actually have to add a new point. So if we call this point up here point B, we would need to look at what's going on at point B. So we'd want to find, for example, YB, which we don't know, that's the h that we're trying to find, but velocity of y at point B we know is 0 meters per second since it's at its maximum height, and then the time to point B, for example, we do not know either, and we don't know the x position, but since we're only asked for the height, we can just look at our y variables. So to solve for this last piece of the puzzle here in part D, we should be able to use our third kinematic equation of motion since we know the final velocity now. So Vyb squared should be equal to our same initial velocity in the y squared plus 2ay yb minus y initial. Again, this will be 0, and so we can actually solve for yb since this too will be 0. And we should find that yb is just going to be our initial velocity in the y direction, 50 meters per second, times the sine of the angle 51 degrees, quantity squared, that whole thing squared, all over 2 times, really, negative ay, so negative 9.8 becomes a positive 9.8 meters per second squared. And so you should be able to solve for yb, which again is at capital H, and it should come out to be approximately 77.0 meters. Boxworthy again. Awesome. So that's a great projectile motion problem there that we got to practice. And so hope that helps. Have a great day.